This video shows our solution to interstellar travel using maths. Different methods include wormholes, gravity slingshotting, the use of solar cells, Alcubia's warp drive, and nuclear fusion rockets.
So, what would be the best method? Most certainly, it's Alcubia's warp drive, which allows for faster than light travel, quicker than all the other methods shown, even light itself, without suffering from any relativistic effects, such as time dilation. It's the best of both worlds of maths and physics and is our best chance at reaching the stars.
How would it work? This method works by expanding and contracting the space-time behind and ahead of the drive, creating a warp bubble around the flat center, which is where the drive would be placed to escape relativistic effects such as time dilation.
So why doesn't this violate Einstein's laws? The object itself is stationary, it's the space-time moving at speeds faster than light, and Einstein's laws do not limit the speed at which space-time can expand and contract.
How to warp spacetime for the drive? Start by finding spacetime's Gaussian curvature using differential geometry, a field of mathematics.
Well, what is a Gaussian curvature? It is a form of differential geometry, the study of curved surfaces. And the Gaussian curvature describes the curvature of a surface using two principal points.
The maximum curvature is the point of the most extreme curvature and the minimum curvature, point of least curvature.
Therefore, the formula for finding the curvature would be the curvature of principal curves is the product of the two principal curves, giving an overall Gaussian curvature value. A sphere, cylinder, and hyperbola are shown. They have Gaussian curvatures of +1, 0, and -1 respectively. As the sphere is constantly curving outwards, the cylinder has a constant flat curve, and the hyperbola is constantly curving inwards. So in curved, flat, and hyperbolic space, the sigma of angles in a triangle would be more than 180, equal to 180, and less than 180 degrees respectively, as can be seen on the diagram shown.
Alcubia's formula. ds2 represents the warp speed variable, which is what we're looking to solve. Coordinates t, x, y, z represent 4D spacetime. FRS is the function determining the warp bubble's properties, and Vs is the ship's velocity.
Components of the warp drive include a spacecraft and torus. The torus is vibrated to create negative energy fluctuations, which would then in turn cause space to warp.
The spacecraft is 240 meters long, 20 meters wide, and 30 meters tall, based from real specifications. Torus has an inner radius of 35, ring radius of 5, and height of 80 meters. This will balance with the length of spacecraft, creating a sturdy structure.
The formula of the surface area of a torus is 4 pi squared rr. Inserting the values, the equation results in a surface area of around 7,000 meters squared.
How much would it cost? Using commercial price of copper, 0.09 meters squared costs £60. Therefore, 7,000 meters squared would cost around £4,666,666.
What would a realistic warp drive look like?
Using ratios for proportion and formulas for the cost, this is our final warp drive blueprint, containing the total estimated cost and each component's price and specifications.